In this video, we will see comparable interface. Comparable interface is used to implement the natural ordering of elements. It is used to implement the natural ordering of elements. This comparable interface is available in java.lang package. So, if any class implements comparable interface, then the elements will be ordered according to the natural sorting order. Here natural sorting order is nothing but ascending order. For example, if the objects has of type numbers, then it will be ordered according to the ascending order, that is 0, 1, 2, 3 and so on. If the object is of type strings, then that will be ordered according to the alphabetical order. And this comparable interface has only one method, that is compare to method. This method compares this object with the specified object for ordering. So the example of this compare to is object 1 dot compare to of object 2. So here object 1 is the newly planning to add element, object 2 is the existing element or specified element. This method returns negative integer if the object is less than the specified object. If object 1 comes before the object 2, then that time this compare to will return negative integer. And this compare to method may return 0 if this object is equals to the specified object. That is, if object 1 and object 2 both are same, then that time this method will return 0. And this method may returns positive integer if the object 1 is greater than the object 2. That is, if object 1 will come after the object 2, then that time this method will return positive integer. So the return type of this compare to method is integer type. So it will return either negative value, 0 or positive value. Based on this value, the objects will be ordered. And this method may throw null pointer exception if the specified object is null. So if you are comparing an object with null, then that time we will get null pointer exception. So this method may throw null pointer exception if you provided value as null. And this method may throw class cast exception also. Class cast exception if the specified object or this object has different types. So whenever we are comparing, that by using this comparable interface, that time the all objects should be of homogeneous. If you are having different types, then they cannot be able to compare. So that time they will throw class cast exception. Let us see how this compare to method will work. So system.out.println of a dot compare to of z, we will give this one. Also we will copy the same and we will use in multiple ways. So next if you see here, we will give here reverse order a dot z, and we will give both are same values we will give. So let us run this one. So here it is giving minus 25, 25 and 0. So if you see in this first case, we have given a dot compare to of z. So this method is returning negative value. So this a will come before z. So in the second statement we have given object 1 is z and object 2 is a. So here it is giving positive. That means this z will come after a. So if you see in this third statement, we have given a. So we have given the same object. So both objects are equal. So it is giving 0. So compare method, whenever it gives negative value, so that the object it will come before the specified object. If it is positive, that object will come after the specified object. If both objects are same, then the return type of this compare to will be 0. So based on these values, JVM will insert or order the data. So how this minus 25, 25, 0 is coming, let us see. Before that, what we will do, a dot chars of dot for each of system dot println. So what this cats method will do, it will return the code point or ASCII value or Unicode value for the given string. So we will use z here, and okay, this is fine. So if you run this one, so let us see what this one is giving. So the code point for A is 65 and the Z is 90. So here this compare to method, what it will give, object 1 minus object 2, it will perform operation and it will give the result. So code point for A is 65. So 65 minus 90 is nothing but code point for Z. So the return is minus 25. So the result of this one is minus 25. So that is the reason it is giving minus 25. So Z code point value is 90. 90 minus 65 is 90 minus 65 is 25. So it is positive value, so it is giving 25. So what code point for A is 65. So 65 minus 65 is 0. That is the reason it is giving 0. Now let us take some other value. Instead of A, we will take some G or something. Some capital G I have taken. So we will use capital G here in the first statement. Let me remove these two statements and let us run again. So if you see here, it is returning capital G code point is 71. So 71 minus 90 is minus 19. So this is how this comparative method will work. So the result, what is the value it is giving, means object 1 minus object 2 is the end result of that method. So here you can able to give not only G, you can able to provide any value. So any string, each symbol will have some specific code, right? Based on that the objects will be ordered. 123 minus 90 is 33. 123 minus 90 is 33. So the comparative method will give result based on the object 1 minus object 2. Now let us see some other examples to understand more about default natural sorting order. So as we know, tree set follows default natural sorting order. If we create a tree set object without any argument, then that time it will follow default natural sorting order. So we will use tree set here. Tree set T is equals to new tree set. So let us add some null value. So if we add any null value to the tree set, so let us see, let us run this one. So it is giving null pointer exception because tree set won't allow null elements. Because why it is not allowing null element? It will internally use natural sorting order. So internally it will use compare to method to check the elements. So tree set won't allow null elements. Let me add some other elements. T dot add of 1 2 3. And let us add T dot add of 1 2 3. So in the earlier case we have added string. Now we are adding different data. So let us see how this one will work. What it is giving? Tree set is giving class cast exception. So string cannot be cast to java.lang.integer because tree set internally uses compare to method. So one type of data cannot able to convert into another type. So whenever we are using tree set or whenever we are depending on the default natural sorting order, then that time objects needs to be homogeneous. Now we will see some other scenarios. Now let us create a tree set object with it will allows only strings. So T dot add of Z, we will give some value and we will give T dot add of some bracket, we will give some open bracket or close bracket we will give. Now we will add T dot add of, we will give some numbers 1 2 3 something we will give, but here we are giving of same type, different type, same data type. So here we are giving string only. So let us print this one T. So now let us run this one. If you see here, it is giving 1, 2, 3, A, Z, L. So whatever the data is there, whatever the elements are there, all elements are ordered according to the default natural sorting order. So let us remove this one to avoid confusion. Let us add some other elements. So we have added string elements in the different order. Now let us run this one and see. So here we are able to see A, C, E, Z. So the elements are ordered according to the alphabetical order because they are strings. So now let us add integer. So we will use integer type, and let us see t dot add of 1, 2, 3, t dot add of, or instead of 1, 2, 3 we will do 1, we will give 9, t dot add of 0 we will give, t dot add of we will give some other value like 7. So now let us print this one. Here the elements are ordered according to the ascending order. So by using tree set we can able to sort all the elements. So now let us see some other examples. Let us try to add tree dot add of new string buffer of A, t dot add of new string buffer of B. So now let us run this one, or we will give jet B we will give. So now let us run this one. So if you see in this result, it is giving class cast exception. What is this giving? Java.lang.string buffer cannot be cast to comparable. So what it is saying? This string buffer is not comparable. So the another important point is, whenever we are depending on the default natural sorting order, the elements must be homogeneous and the elements must implement the comparable interface. In the earlier case we have seen string classes, that elements are ordered, integer elements, that elements are ordered. So why their elements are ordered? They internally implements comparable interface. So let us see whether string, let me see string, and let's go to into this string implementation. If you see here, string class implements serializable and comparable interface. So string class implements comparable interface. That is the reason we are able to do the default natural sorting. So if you use integer, and if you see integer, and let us go to this integer class, here also it is implementing comparable interface. So comparable interface it is implementing. So by default, string and all wrapper classes implemented this comparable interface. So happily we can able to use default natural sorting order, but in this case string buffer is not implemented. If you see here, let us go to the string buffer class, and let me go to the headers one. So if you see here, string buffer, it is implementing serializable and character sequence only. It is not implementing comparable interface. So if you want to perform default natural sorting order, or if you want to add any elements to the default constructor of tree set, then that elements must be homogeneous and comparable. So based on these examples, we understand that string and all wrapper classes implements comparable interface. String and all wrapper classes implements comparable interfaces. If we are depending on default natural sorting order, compulsory the object should be homogeneous and comparable, otherwise we will get class cast exception. So we have given different type of data, integer and string, different data we have given, so we are able to get class cast exception. And we have given the string buffer class, so this string buffer class is not implementing comparable interface, that is the reason we get class cast exception. So if an object is said to be comparable if and only if the corresponding classes implements comparable interfaces. So string, integer, all wrapper classes are internally implements comparable interface. That is the reason we are happily able to sorted here. This string buffer is not implemented comparable interface. That is the reason we get that class cast exception. So this is all about what is comparable interface and other examples for this comparable interface. So this is all about this video. Thanks for watching.